Hello everyone, this is Teacher Marichu and welcome to our learning activity on Mathbox for Senior High School. Let's get started! Exercise number 1. Directions. Find the center, vertices, co-vertices, and the foci and the asymptotes of the following hyperbola. For number 1, we have x minus 1 quantity squared all over 25 minus y plus 2 quantity squared all over 4 equals 1. For the solution, the center of the hyperbola is at 1, negative 2. We have here x minus 1, so this is h, and we have negative 2 equals k. So this graph in figure 1 shows you the properties of a hyperbola with its corresponding attributes. In this case, the center is at point hk, and the equation of this hyperbola is of this form: x minus h squared over a squared minus y minus k quantity squared all over b squared equals 1. So this equation is similar to this form of equation of a hyperbola. So take note that we have the transverse axis is at point or is at y equals k. The line is parallel to the x-axis. Let's examine here that this part over here, the 25, is actually a squared. So giving us a equals 5. And this is b squared equals 4. And we have b equals 2. Solving for c, we need this formula: c squared equals a squared plus b squared. We're given with the a squared and the b squared. So we have a squared 25, b squared is 4, and c will be now the square root of 25 plus 4, or simply the square root of 29. The c here is, this is the distance of the focus, one of the focus from the center going here. Somewhere here is the focus. From this center going to the left, somewhere here is the focus. So that is, in this particular standard equation of the hyperbola, our focus is square root of 29 units. And our b indicates the distance of the co-vertices from the center. So this is the center going down, that's b units, 2 units down, or from the center up, that's 2 units up. Okay, but this in the figure, the hyperbola here, center is at hk, vertices, we have a coordinates of the vertices are h plus a k and h minus a k. Then co-vertices, we have this, and so on. So we have here the following table to show our solution for the final one. This is what actually is asked in the problem. We have to find the center, the vertices, the co-vertices, the foci, and the asymptotes. In the context of the problem, we already found a and b, and of course c. C is square root of 29 in the previous slides. So we have here hk center is, as I mentioned earlier, it's 1, negative 2. And for the vertices lies at h plus or minus a k. So we have h is 1, then plus minus our a is 5, then our k is negative 2. Simplifying this, we have 1 plus 5, 6, copy negative 2, and here 1 minus 5, we have negative 4, copy negative 2. So the coordinates of the vertices lies at points 6, negative 2, and negative 4, negative 2. For the co-vertices, we have here the guide, the coordinates. We have 1, then the k is negative 2, plus or minus the b, which is 2. So simplifying this, we have 1 and negative 2 plus 2, 0, and 1, then negative 2 minus 2, it's negative 4. So the coordinates of the co-vertices of this hyperbola is given to be at 1, 0, and 1, -4. For the foci, we have here h, which is 1, then plus or minus the c, we have square root of 29, and the k, which is -2. So we have here 1 plus square root of 29, -2, and 1 minus square root of 29, -2. So these are the coordinates of the foci. For the asymptotes, we have y equals k plus or minus b over a times the quantity x minus h. So we have here for k, that's -2, then plus or minus b is 2, then a is 2/5. Then quantity x minus our h, which is 1. So this concludes the solution for number 1. Moving on to number 2, we have x minus 4 quantity squared all over 25 minus quantity y minus 6 squared equals 1. By inspection, this is our a squared, and the denominator of the second term here is our b squared. So our a squared is actually 25, which gives us a equals 5, and b squared equals 1, which gives us b equals 1. And for determining the value of c, we have here c squared equals a squared plus b squared, or that is 25 plus 1, that's 26. Take the square root of that to get a value for c. So our c is square root of 26. Then, by just looking at the numerator of both terms, the center is at 0.46. And in this case, we have here is transversing, or meaning the transverse axis of this hyperbola is at y equals 6. So we have here the properties and attributes in terms of a, b, c, and the points, the center of the hyperbola. So for the asymptotes, we have the equation of the asymptotes must be equal to k plus or minus b over a times the quantity x minus h. So moving on to the table that is required for us to answer. So for the center again, 4, 6, then vertices, we have h plus or minus ak. So the h is 4, plus or minus our a is 5, and k is 6. So simplifying, 4 plus 5 is 9, then that's 6, then 4 minus 5 is -1, then we copy k equals 6. So the points or the coordinates of the vertices are 9, 6, and -1, 6. For the co-vertices, we have h, which is 4, and k is 6, plus or minus b is 1. So we have it here. Simplifying, we have copy 4, then 6 plus 1, 7. Then another one is copy 4, and then 6 minus 1 is 5. So the coordinates of the co-vertices are at points 4, 7, and 4, 5. For the foci, we have h plus or minus k, and k. So we have 4 plus or minus our c is square root of 26, and k is 6. Simplifying, we have two coordinates as 4 plus square root of 26, 6, and 4 minus square root of 26, 6. For the equation of the asymptotes, we have y equals k plus or minus b over a times quantity x minus h. So k is 6, then plus or minus b is 1, a is 5, and then copy x minus the h, which is 4. This is now our solution for number 2. Moving on to number 3. Number 3, in this case, the transverse axis for number 3 is actually a vertical line. First two examples, we have transverse axis and the horizontal axis, which is parallel to the x-axis. But this time, we have another figure 2, wherein we have hyperbola, in which we have here the transverse axis, that is the axis where the center and the vertices are collinear with each other. So we have a vertical line here. So number 3, we have y minus 1 quantity squared all over 25 minus x minus 2 quantity squared all over 11 equals 1. Now the center of this hyperbola is at, we have our h2 and our ks 1. So it's at 2, 1. Here, the transverse axis is x equals 2 because somewhere here. So this is the center. Just imagine it is the center, and this point, the point coordinate is 2, 1. And this is the vertical line is the transverse axis, having the equation x equals 2. By inspecting the standard equation of this hyperbola, this is a. Okay, that's where, this is a squared because we get here the vertices. This is our hint in getting the vertices and the coordinates of the vertices and of course the co-vertices. So this is a squared. So a squared is 25, giving us a equals 5. Then our b squared is 11, giving us b equals square root of 11. And then we have here this formula c squared equals a squared plus b squared. To get the value for c, we have c is square root of 36 or simply 6. So the attributes, remember these attributes of the hyperbola in which the transverse axis is a vertical one parallel to the y-axis. So moving on to the table, we have here the hyperbolic equation form. So this is it. And the center HK, we have at 2, H is 2, and K is 1. Okay, we have it here. That's the final answer for the center. And for the vertices, we have H and then K plus or minus A. So H is 2, and then we have K is 1, then plus or minus our A is 5. So simplifying, copy 2, 1 plus 5 is 6, and copy 2 again, then 1 minus 5 is negative 4. So we have here the two coordinates of the vertices. Then the co-vertices, we have H plus or minus B, K. So our H is 2 plus or minus the B, which is square root of 11, and K is 1. So we have the two coordinates of the co-vertices. We have 2 plus square root of 11, 1, copy 1, and 2 minus square root of 11, 1. For the foci, we have H, then K plus or minus C. H is 2, then K is 1, plus or minus the C, in which we add this, and then 36 square root of 36 is 6. So we have copy 2, and 1 plus 6, 7. Copy 2 again, and then 1 minus 6 is negative 5. For the equation of the asymptotes, we have K plus or minus A over B times quantity X minus H. So our K is 1 plus or minus A, which is 5. And your B is square root of 11 times quantity X minus 2 for H. And we don't need radicals on the denominator, so we have to rationalize. So this simply multiply square root of 11 all over square root of 11 so that the denominator becomes 11. So final answer for the asymptotes, y equals 1 plus or minus 5 square root of 11 over 11 times quantity x minus 2. Moving on to number 4, we have y plus 4 quantity squared all over 4 minus x minus 3 quantity squared all over 9 equals 1. So in this case, you already have the idea. Where is the transverse axis? Is it a vertical or a horizontal line? Well, in this case, it's actually a vertical line. Yes, here. Center is at 0.3, negative 4. That's correct. And it's a vertical line wherein we have x equals 3. These are the coordinates of the corresponding center, co-vertices, vertices, foci, and asymptotes that is required in this problem. So moving on, so by inspection, we have a squared equals 4, giving us a equals 2. And b squared equals 9, giving us b equals 3. And solving for c in terms of a and b, so we start off with, this is supposed to be plus. We start off with a squared plus b squared, so that's 4 plus 9, that's 13. And then we have the value of c equals square root of 13. For the table here, we have center at HK. So again, let's have our H is 3 and our K is negative 4. Then vertices of this hyperbola is at H, K plus or minus A. So our H is 3 and then K is negative 4 and plus or minus our A, which is 2. Then simplifying, you copy 3, then negative 4 plus 2, that is negative 2. Then negative 4, negative 2, that is negative 6. So the coordinates of the two vertices of this hyperbola is, or lie at 3, negative 2, and another point 3, negative 6. Moving on to the co-vertices, we have H is 3, plus or minus the B, which is 3. Then we have the K is negative 4. Simplifying, 3 plus 3 is 6, copy negative 4, and 3 minus 3 is 0, so copy negative 4. So we have coordinates at 6, negative 4, and 0, negative 4. These are the co-vertices. And the co-vertices are at the co-vertices, the line segment connecting the two co-vertices is parallel to the x-axis, because the transverse axis is a vertical one. For the foci, we have H is 3, and then we have K negative 4 plus or minus the C, which is square root of 13, giving us copy 3, then negative 4 plus square root of 13, and copy 3 again for another coordinate. We have negative 4 minus square root of 13. For the asymptotes, we have K is negative 4 and then plus or minus, the A is 2, the B is 3, and then quantity X minus H. Okay, this concludes our solutions for exercise 1 in this learning activity. Moving on to exercise number 2, directions. Find the standard equation of the hyperbola centered at HK with the given conditions. And this time, we are given a few conditions like the foci and the vertices. Then we are to find its standard equation. So based on the foci and the vertices, we have only 4 coordinate points, and we're going to get the equation of our hyperbola, wherein this contains the points. So how to get it? Let's have it here. Again, let's recall that how do we know that this is the form of the equation of our hyperbola based on the given conditions, such that the focus 1 lies at point 4, negative 2, and another focus at negative 6, negative 2. So take note, negative 2 is steady, or it's constant. So where is it negative 2? Negative 2 is along the y coordinates. So somewhere here, negative 2. So if we plot on the line, so we have something 4, negative 2, somewhere here is 4, and negative 2 is here. And negative 6 is somewhere here for x, then negative 2. So meaning the transverse axis here lies or parallel to the x-axis. So in this case, this is similar to this hyperbola. Well, we have a steady negative 2. Of course, the y-coordinate of the center also is at negative 2. But we need the x-coordinate. Where is the x-coordinate? Okay. So meaning, from these given conditions, we have the hint that K has coordinate negative 2. But what is our H? How did we get negative 1 for the H? So we have negative 1, negative 2 as the center. So somewhere here, negative 1, negative 2 is the center of this hyperbola. Well, here, 4 plus minus 6. So just get the midpoint of this and divide it by 2. So 4 plus minus 6 is equal to negative 2 divided by 2. That's negative 1. Oh, sorry, there's a cut, but this is supposed to be negative 1. And on another point, we have here the clue again. It has to be that the foci midpoint of the x-coordinate of the foci and the midpoint of the x-coordinate of the vertices are equal. So they have to be the same with negative 1. Let's see. So 2 minus 4, that's negative 2, divided by 2, it's negative 1. So we have our h to be negative 1. Hyperbola centers at negative 1, negative 2. How to get the a? Well, we know that we have the vertices, and these are the endpoints of the two vertices. Okay, since the vertices is parallel to the x-axis, so we just have to get the distance to add the coordinates, add the absolute value of the coordinates of the vertices, only the x coordinate. So in this case, we have 2, absolute value of 2 plus the absolute value of negative 4, which gives us 6. And we equate it to 2a because the distance or the length of the vertices, the line segment that is formed by the given vertices, is the length, that's 2a. The length of the vertices is 2a. So we have 6. 2a equals 6, but we have to divide it by 2 to get the value of a. In this case, a is 3, giving us a squared equals 9. We need the value for a squared and b squared, and then we're done with the equation of this hyperbola. But we don't know b. There's no idea for us to get b. But all we know is the two foci. The two coordinates of the foci are given. And since negative 2 is fixed or constant, so we have to get the distance from 4 going to negative 6. That is 10. That is 2c. So twice of the length of the foci from the center going to the foci. So 2c equals 10, giving us c equals 5, c squared equals 25. So by this property that c squared equals a squared plus b squared, then we can get b squared, and that is equal to c squared minus a squared, or simply b squared equals 25 minus 9, and that is 16. We don't need to get b. So the final answer is x plus 1 quantity squared all over 9, because we have here our a, because we have to get this equation of the hyperbola. So minus quantity y plus 2 quantity squared all over 16. Our b squared is 16 equals 1. Now, y plus 1 and y, why is it it's 2 here? Well, the center is at negative 1. So we have x minus minus 1, that is x plus 1. And we have the k is negative 2, so we have y minus minus 2, or simply y plus 2. This concludes our solution for letter A. Moving on to letter B. We have here foci 1, 7 and 1, negative 3, and vertices 1, 6 and 1, negative 2. So based on the given condition, again, we have a fixed h is fixed. So this simply shows that our h is 1. And the parabola, or the hyperbola looks like this. And the expected equation that we're going to have is something like of this form. Y minus k quantity squared over a squared minus quantity x minus h squared all over b squared equals 1. So we need the a squared and the b squared. Okay. Getting the midpoint of the y coordinates of the foci and the vertices. In this case, let's get the midpoint of 7. That's supposed to be plus negative 3, or simply 7 minus 3, that's 4 over 2, that's 2. And we have here 6 plus negative 2, or simply 6 minus 2, that's 4 all over 2, and it's equal to 2. So we have our k, the midpoint wherein that is the center. So we have the center is at 1, 2 here. And our foci is at 1, 7 somewhere here. And another point 1 somewhere down there, it's -3 somewhere the foci. Vertices are at 1, 6. 1, 6 here. Just imagine. And 1, -2. It's supposed to be lower than this. So anyway, this is a generic figure. This is our guide in finding out the equation of the hyperbola given these conditions or given the coordinates of the foci and the vertices. Okay, hyperbola now centers at 1, 2. How to get A? Well, 2A is equal to the distances. In this case, we have a vertical distance of 6 and 2, -2. So we get the absolute value of the y coordinates. And this gives us 8 equals 2A. And isolating A, that means we have A equals 4, then A squared is 16. Based on the foci, we have here 10. 2C is 10. C is 5, giving us C squared is 25. And finally, B squared equals 9. So the required equation is y minus 2, our k, quantity squared, all over A squared, which is 16, minus x minus h, we have 1, all over, quantity squared, all over b, which is b squared is 9 equals 1. We're done with B. Let's move on to C. Focus 12, 3, vertex 4, 3, and we are given the center at -1, 3. So we have a fixed y coordinate and we have a moving x coordinates. It's not constant. So we have an example of this hyperbola in this case. We have a different x's. Fixed value for k is 3. So we have a horizontal transverse axis, and we are expected to have this kind of equation of the hyperbola. X minus h squared all over a squared minus y minus k squared all over b squared equals 1. So it says in the solution, based on the given conditions, k equals 3. Then getting the value of a is getting the distance of the x coordinate from the center to the vertex. Let's get the distance from the center to the vertex. So this is 4 plus the absolute value of -1, which is 5. Okay. How about C? To get the value of C is to evaluate the distance of the x coordinate from the center to the focus. So we have the center -1, absolute value is 1 and 12, so 13. C squared is 169. And going back to A, we have here -1, positive 1. Distance, absolute value of -1 is 1 plus 4, that's 5. Then A squared is 25. So B squared finally is actually 169 minus 25, that's 144. So we have the center, we have the A squared and the B squared. Final answer is x minus 1, quantity squared, so that's x plus 1, quantity squared, all over the a squared, which is 25, minus y minus 3, quantity squared, all over the b squared, 144 equals 1. So this is our solution for this particular learning activity. And don't forget to like and subscribe in this video. And write your comment below so that this is for improvement, and I will be happy to reply to your queries whenever there is such a query. And again, this is Teacher Marichu saying stay happy, healthy, and safe. God bless us.